Here's an interesting question. It has the number 365 in it. And I promise you, there's always a very good reason why I choose all of my numbers. 365 is the number of days in a year, which has nothing to do with the rest of the question, apparently, but we'll see something interesting about it anyway. Suppose a teacher is giving candy to her class. To each girl, she gives a number of candies which is equal to the total number of girls in the class. So for example, if there were 10 girls in the class, every girl would get 10 candies. To each boy, she gave a number of candies equal to the total number of boys. She actually distributed exactly 365 candies in all. Maybe it's because when she came, the idea was to give one candy a day, and maybe everyone decided they wanted them all now. Well, the number of girls is exactly one more than the number of boys. From this, can you figure out how many girls there are in the class? This actually looks like an algebra problem. Because you see, all together it's 365. And there's something we're solving for, which is the number of girls. A tip I will give is that if you're trying to solve for an answer, for something that you want to give at the end, it's useful to call that x. So suppose the number of girls in the class is x. How many boys are there in the class? Girls are one more than the number of boys, so boys are x minus 1. Now, if she's giving away candy, for every girl, she's giving x candies. So the number of candies she gave to all the girls is x squared to girls. And the number of candies which she's giving to the boys is just going to be x minus 1, whole thing squared. That brings us to a nice equation. X squared plus x minus 1 squared is equal to 365. Well, how do you solve an equation like this? Let's expand the brackets. X squared plus x squared minus 2x plus 1 equals 365. I do want to say, I understand that some of the people who are watching this might not have taken algebra yet. I promise you there will be another way to do this at the end where you don't even need this algebra. But I'm showing this, especially if you haven't seen algebra yet, to see how powerful it can be. And the way I expanded this is that x minus 1 whole thing squared. Let me just give that as a quick review because I don't expect everyone to have taken algebra. X minus 1 times x minus 1, you multiply the x's. Now you multiply the x and the minus 1. You multiply this x and the minus 1. And then you multiply the two minus 1s. And this is this piece right here. Now we put everything together. And if we bring things to the same side, then we find that 2x squared minus 2x minus 364 is equal to 0. Here's an equation where all of the numbers are even. And so what's going to be very convenient is I can divide both sides by 2. And then I will find that x squared minus x minus 182 equals 0. At this point, the nice thing to do is to try to factorize 182 so that we can write a pair of brackets like this in a way where I'll get the 182 at the end. For that, I need to prime factorize 182. 182, I see a 2, and then I see that I'll have a 91. And throughout all of the things that I've been teaching, I've been telling to remind people, 91 is 7 times 13. Because otherwise, if you don't know that, you can sometimes accidentally think that 91 is a prime. So now I know 182 is 2 times 7 times 13. And so the factoring method of solving a quadratic equation is one where I want to find two things that multiply to 182, but have a difference of only 1. That's perfect. I see that, because I can see I can make a 14 and a 13. So, to finish this, let me rewrite the equation. X squared minus x minus 182 equals 0. Because of the fact that 14 and 13 work in this way, I can do x plus 13, x minus 14. And this left side is the same, because the 13 times 14 gives you the 182 with the minus sign. The minus 14x and the plus 13x fit here, and the x squareds are there. And so what this means is that therefore x is either equal to minus 13 or x is equal to 14. So there are either minus 13 girls or 14 girls. I've never seen a class with minus 13 girls, so that can't be right. And so there are 14 girls. Now, that's nice. I've just found out that if I have 14 girls, this all works. Always double check at the end, because we have done a whole bunch of algebra, a bunch of calculations. What if we made a mistake? Let's just try to see what it looks like if those were the actual numbers. 14 girls. 14 girls means that there are 14 squared candies, which is equal to, let's see, 14 times 14. 4 times 4 is 16. 4 times 1 is 4, 56. Here's the 1, 4. So I have 6, 9, 1. 196 candies have gone to the girls. How about the boys? Well, 13 boys. So 13 squared is equal to, if I multiply 13 by 13, let's do it over here, 339, 39, 13, 169. 169. I always thought this was a nice coincidence, how 14 squared and 13 squared had the same digits. But what this is saying is that if I add the two together, supposedly what this means is that 6 plus 9 is 15. Then I have a 6 with an extra 1, 365. How nice! This actually proves that actually the number of days in the year is 13 squared plus 14 squared. That's a neat coincidence. Quite possibly will come up in a math problem somewhere. Okay, here's how to do this question if you know how to use algebra. But let me now show you another way to do it, which is actually even faster and doesn't even need algebra at all. Let me first ask an easier question. The easier question would be if I took this original problem and I change it a bit. The change I will make is I will say to each girl, she gave not a number of candies equal to the total number of girls, but she gave 1 candy. And to each boy, she didn't give a number of candies equal to the total number of boys. She gave 1 candy. If that's my question, and she gave 365 candies in all, how do you find out how many girls there are if there's one more girl than boys? Well, what you'd say is that clearly the number of girls is just half the number of candies, half of 365, rounded up. Oh, wait. What I have instead of that, in my actual problem, I have not x plus 1. I have x squared plus, sorry, I don't have x and x minus 1. I have x squared and x minus 1 squared. So actually, the way to do this is to say that 365 is the sum of 2 squares that are right next to each other. So maybe what I should do is I should try to see what is half of 365 and see what squares are around that. No algebra is needed anymore. What is half of 365? 365 divided by 2, I'll actually just write on top. I can see it here. It's 1/8 because 18 times 2 is 36, and 2.5 at the end. What perfect squares do I know that are around that? That's actually why it's useful to see a few perfect squares. And with 10 squared, that was 100. 11 squared is 121. It's good to know how big these are. 100. 11 squared is 121. 12 squared is 144. 13 squared is this 169. And 14 squared is 196. Especially if you do a lot of math problems, it's useful to know these squares. But look, I cross through 182.5 right here. And actually, that's how I know that the answer has to be 13 boys, 14 girls. Here's why. Because suppose that I have two numbers, both of which are perfect squares. Suppose both are less than this green line. If both are here, then their sum is going to be too small. Because what I need is that the average of the two perfect squares is 182.5. If I take the average of any of these two perfect squares, it's less than 182.5. If I take the average of any of these perfect squares, it's more than 182.5, and so the only consecutive perfect squares whose average could possibly be 182.5 has to be these two. No algebra needed, just reasoning and logic. So in the end, this gives another way to get the same answer. It's guaranteed that the answer exists because the problem was asked, and so there has to be a way to add these whole numbers together. But it's useful to know these different ways. Sometimes the algebra is necessary because there might not be any other way. But sometimes, if you can think about things like this, you can save yourself a lot of time. And remember, the number of days in a year is the sum of two consecutive perfect squares.